I hope you all had a very nice Christmas and that you have a very nice New Year. I'm posting this video, it'll just be a short video, and it's in response to a comment I received fairly recently. And initially I hand-waved the comment away. Now the comment was on a video where I showed this power supply. It's a very low cost power supply, but it's fairly unusual because it incorporates a digital multimeter. So this is an 01 SPM 6103, and the reason I hand-waved the comment away initially is because the comment said that I didn't attach a scope to the output of this to show the noise. Now the reason I hand-waved it away is because the title of the video was a very brief look at an SPM 6103, so it was never intended to be an in-depth review and performance analysis of this. It was just really showing it and introducing it and making people aware that it existed. Now this does not claim to be a top level linear supply. It is, of course, the output's 50 volts 10 amps 300 watts, so clearly a supply of this size can't be linear, but then it's 1/5 of the price of an equivalent linear supply. So clearly it's a switching supply, and I have in previous videos gone over the pros and cons of using switching supplies. I've posted a number of videos assembling low cost power supplies with switching back ends. I even posted a series of videos where I showed how I made a linear back end for one of those supplies and why I did it, and that was specifically to reduce the noise output. So after I'd kind of dismissed the comment and pointed out that I never intended to do a full review, I was thinking about it over the following few days, and the comment does raise some interesting points. The first thing was that it was pointing out some videos where other people had attached a scope to the output of the supply to, in his words, analyze the output, and they had not recommended this supply because of the noise level on the output. Now I've set up a similar sort of arrangement here where I've got an electronic load, the supply, and of course the scope, and the scope's attached directly to the output, but this is not the way to analyze the noise output of a power supply. I ran my own businesses for many years, and part of that process I developed some equipment for the medical field, pharmaceutical, that sort of thing, and so the equipment had to pass some very strict and stringent directives and standards, such as EMC, susceptibility, emissions, that sort of thing, and other standards that you've probably never heard of. But the pre-EMC testing that I did, so that I could be fairly sure it would pass the EMC testing when I subjected it to that, I didn't want to spend thousands of pounds having the testing done if I wasn't reasonably sure it was going to pass. But you cannot do noise testing like this, and I've explained in previous videos why that is. If you want me to go into this topic in more detail, because it is a very big topic, there's an awful lot involved in getting proper testing of noise output on power supplies or anything else for that matter, and you cannot do it by simply attaching a scope to the output. Now what we've got here, of course, is the SPM 6103 attached to a Kunkin KP184 electronic load. I've got the supply set to 12 volts 1 amp, and that's what it's currently running at. I've got the scope attached directly to the output, and if we turn this up, so we've now got 200 millivolts per division, and as you can clearly see, there is significant apparent noise on the output, and it's peaking up around plus or minus about 250 millivolts, so about half a volt peak to peak, which is apparently quite high, but that's not really what the whole story is. And just dismissing the use of a power supply like this simply because you've attached a scope and you see this, I don't think is very helpful advice. If you got one of these for Christmas, then don't worry, things are not as bleak as they seem at this point. So just attaching a scope like this, posting a video and saying, no, it's no good, it's too noisy, I don't think is very useful to anyone. I think it's, while it might be interesting to do this as an exercise, I don't think it really helps anyone unless you fully qualify what you're looking at and then why it's an issue. So if you see this, is this an issue? Does it really matter? And the answer is probably 95% of the time, no, it doesn't matter. This is not going to make its way into your device anyway. We'll demonstrate that in a few minutes. But also, if it does make it into the device, is it going to stop it working? So when I showed the original video on this, I was saying that the reason I bought it is because I quite often run projects on tests for extended periods, and I want to take measurements and not tie up the rest of the equipment in the lab. So using something like this, I can run projects for extended periods. So I've got a few of these, and obviously it makes it quite easy for me to leave things running without tying up the expensive linear supplies. And I've never had an issue with noise. Now, you wouldn't use it for running something like a ham radio setup. You wouldn't use it for doing sensitive development of amplifier circuits and that sort of thing. You could, and I'll show you how to get around the noise issue in a minute. But if you're doing that sort of thing, then really you are going to need to pay extra for a linear supply, or just make a linear supply with rectifier and capacitors. That's very easy to do. It takes just a few minutes. That's not really what this is for, but as I say, if you're going to dismiss this based on the noise, at least qualify that and say why that is going to be an issue, because as far as I'm concerned, for the vast majority of people, especially the sort of people buying this, that it's either for a backup supply, or it's because you're getting into electronics and you need a cheap supply to get you started. As far as I'm concerned, something like this is ideal. I've got no affiliation, by the way, with the manufacturers and supply of this. I bought this, so I'm not trying to promote it. I'm just saying that supplies like this, not just this one even, but other supplies that may appear to also give out noise like this, should not be dismissed simply because you've hooked a scope up and you see something like this. So what I'll do now is look at how to minimize this noise if you are concerned about it, and also try to explain why this is not really an issue for most of the applications that this sort of supply would be used for. So firstly, this is not an appropriate way to measure this, but we will carry on using the scope like this, or in a way to measure the noise, because this is what most people will have. But as I said, this is not really the way to measure noise. You need to isolate and measure current, not what might be emitted noise. But as I said, we won't go into that in this video. That's quite a big topic. But the first thing is, you should not use an electronic load if you're doing noise measurements, because the electronic load, they quite often introduce switching noise themselves. And again, bear in mind that probably 90% of the equipment you have will have a switching power supply in it. So just bear that in mind. A lot of noise you'll see will be coming in through the mains, and you'll get a lot of interaction. I have explained this and demonstrated this in previous videos, but the first thing we want to do is get rid of the electronic load and just use a static loads. So I'm going to use a power resistor here. So I'll get this set up. All I'm going to do is disconnect the power supply from the electronic load and connect it up to this resistor. So I've got rid of the electronic load and I've fitted a power resistor in its place. And so you can see things look even worse now than they did, although the peak-to-peak noise is still the same. It's about 500 millivolts peak-to-peak. But this is not all as it seems. The noise that's coming out of the supply, it's not noise superimposed on the ground lead. You can see this is symmetrical, so although I've got the scope set to AC, it means that what we're getting here is what amounts to an AC noise. It's really a current on the leads coming out of the supply. but this will not generally make its way into a device that you attach. If you're going to do this sort of testing, you need to properly load up the supply and load up the equipment you're measuring it with. Remember, a scope has got a very high input impedance, so the scope is partly responsible here for this noise being present. So even if you were to shorten this scope probe or get rid of the scope probe completely, then you'll see a very different result on the scope. But what I'm going to do here instead is just make a filter to go on to the output leads of the power supply and demonstrate that you can get rid of this. But I'm going to effectively simulate a piece of equipment that you would attach to this power supply. What I'm trying to get at here is not to say there isn't noise coming out of the supply, but that the noise coming out of it isn't necessarily just a positive going noise that's going to inject current spikes into your equipment. So what I'm going to do is take a pair of coils. So these are what we'd normally use for a switch mode power supply. Incidentally, I will get back onto the switch mode power supply project sometime fairly soon. But if you're going to do this, don't use the non-gapped cores. If you look at the center part of these cores, the RAM part, notice that they meet in the middle. So this is non-gapped. You don't want to use this sort of thing for this application. What I'm going to use instead is a gapped core. So if you look at these, you hopefully can see there's quite a big gap in the center section, and we need to use this sort of core to properly filter out this sort of noise. Okay, so what I'm going to do is use our cores to make a simple filter. Now before I do that, just to give you some indication as to what we're likely to see, even if we can reduce all the switching noise, is firstly I will remove the positive terminal from the supply, but notice we're still getting noise on the scope, and this is what I meant about this not being a suitable way to measure noise like this. So I've got this reference to an external ground, and the scope, by the way, is connected through a filtered main supply. But you can, if you want to, run scopes like this from a series of batteries. In fact, I have several power tool batteries that I use in series, and if you have 6 batteries in series, 6 20-volt batteries in series, it will run something like this for a day, and that will remove a lot of the noise coming into the mains supply of the scope. So you can see this hasn't completely got rid of the noise, but it is coming through a path that includes the supply. But I'll turn the power supply output off, and notice the noise is still, it's about 100 millivolts peak to peak, so it hasn't gone away completely, it's still there. If I disconnect this, it does go away, so it is definitely because we're going back through the supply, but it's not all the switching noise that will make it through into your device. So we'll reconnect this, we'll turn the supply back on, and notice we've got the noise back. So what I'm going to do now is take one of the cores. So working around the camera here, so I'll try to knock you. I'm just going to wrap the 2 wires side by side that come from the power supply. I'm going to wrap those through the core. The more times we do this, the more filtering effect we'll get, but these are quite thick wires, so I can only run them through a few times. They're also fairly short, of course, so that's as many as I can get through there. So the noise has gone down, but not significantly. But what we'll do now is put the second part of the core on. So if you now look at the scope, you'll see that most of what's left there is that background switching noise that we saw, which is why this is not a suitable way to measure noise, because you're not really looking at what you necessarily think you're looking at. You're looking at system noise, and that's what you have to eliminate when you're doing testing like this. But if you are concerned about the noise output level on a supply like this, then of course you can just make up a simple filter, put a few more turns than this on, use thick enamel copper wire, put maybe 40 turns on there, and you'll pretty much completely eliminate the noise that's coming out, the conducted noise that's coming out of the power supply. If you wanted to, there is space inside these supplies to build this inside the supply. It wouldn't be that easy to do inside a supply like this because of the way that the terminals are attached to the front panel. But you could certainly do it. You could disconnect those terminals from the front panel, build one of these into it, and then connect it directly between the two. And that way you'd get something that, it wouldn't be as low a noise as a true linear supply, but it would be certainly a lot lower than the noise level you get without the filter on here. Okay, so the last thing I'll do in this video is, just by way of comparison, I'll connect the load to our O1 linear supply. The supply I'm going to be using is an ODP 6033. I'll set it to 12 volts and connect it to the resistor, but I won't change anything else. All I'm going to do is unplug the lead from here. Unfortunately you can't see the supply. But I'll raise the camera a bit, see if I can get the supply into the shot. Okay, hopefully you can see it, and we'll set this to 12 volts. Okay, and we'll switch it on and see what we get on the scope. So you can see there's even noise on here. Just make sure we're not getting this from the supply, so I'll turn this off. Okay, so even on a linear supply you can see we're getting noise. And like I said, there's lots of things that can create noise. I'll turn this up a little bit so you can see there's still noise on here. So it's not like a linear supply is going to give you zero noise output if you measure it like this. So even though it's linear, it's complete linear supply, we're still getting noise from somewhere. And as I say, that's because this is not the correct way to measure noise from a power supply. But hopefully this gives you some confidence if you've got one of these supplies. So as I said, it's an O1 SPM 6103. If you've got one of these and you're concerned about the noise, then it's not the end of the world. You can do something about it, but also it's probably not that important anyway. As I said, I use this unmodified for almost a year now, haven't had any issues whatsoever because of the noise, so I certainly wouldn't dismiss it or its use based on its noise output level. And I have seen more expensive switching supplies with far worse noise output than this. So like I said, the reason for posting this video is just I don't like seeing advice that's incomplete. So this advice is incomplete. Having said that, it's I haven't shown the correct way to measure noise, but really what this video is aimed at is just to say, don't be concerned if you've got one of these. You can't really use it for ultra precise equipment. If you're developing instrumentation, it's probably not suitable, but certainly for most general workshop use, this is good, and it's been ideal for what I want it for. So clearly you can see that filtering the output of the supply makes a huge difference, and even with the linear supply we're still getting noise present on the scope. So it's not just the supply that's creating what we're seeing on the scope, which is why I was saying this is not the right way to test this setup. The correct test setup for something like this is far more complex, and you cannot do it with a single-ended scope like this. And I'll give you an example as to the sort of problems and the reason you can't do it, and I have touched on this in videos in the past. If we take another core here, and all I'm going to do is pass the ground lead for our scope through it. I'm going to take the second half. Doesn't seem to have made much difference. I'm going to take the second half, but if you watch what happens now on the output of the scope, notice we've doubled the noise reading. Even though nothing's changed on the power supply, we've now doubled the reading of the noise that we're seeing on the scope. And just to prove it's not a fluke, I can remove this and it goes back down, put it back on, and it comes back. So in fact we'll try this with the gapped core as well. This is the ungapped core. If we try this with the gapped core, so as you can see, it does the same thing. What will happen if we put 2 on here? And this is the sort of experimentation that's a lot of fun to do, and you can learn a lot doing this if you follow it through and look into the causes. So you can see the more inductance we have on that ground lead, the worse this gets, which is kind of strange. It might seem a bit counterintuitive, but that's because of the nature and the source of this noise, and that's something that's well worth looking into. But as I say, that's why you can't use a simple setup like this. We put the main lead from the probe through. Notice it actually reduces the noise. So like I said, the reason this is doing this is because we're taking an imbalanced load reading from the power supply, and because this is kind of impulse noise, then we're not really reading directly what appears to be appearing on the scope screen. So it is important to correctly set up any tests that you intend to carry out like this. You cannot do it with a single-ended scope lead. You need to set it up with a properly balanced. Effectively, you need to measure the currents that are flowing through the system, not the voltages that are floating around, because as I've said in the past, that can mislead you to quite a remarkable extent, and you end up with readings that are maybe 10 times worse or better than you would otherwise get. And you do need to properly set up any tests that you're going to carry out if you include noise. That's why I don't normally do this on a simple introduction to a supply, especially a switching supply, because you can end up misleading people and making a supply seem far worse than it actually is, or even end up saying that they're unusable, which is what I've seen a few people saying, because they've been carrying out testing in a non-specific way, an invalid way. That's not to say there is no noise coming out of this supply. There is, but it's not normally going to be an issue by the time the power gets into the device that you're trying to run from the supply. So as I say, I hope that's been of some help to anyone with one of these, or even another type of switching supply that they've been trying to measure, or that you've been trying to measure using this method. And as I say, if you want me to go through the correct way of taking noise measurements from a power supply, then leave a comment. It is quite a complex topic, and the equipment you need is fairly complex as well, but certainly this is not the way to do it.